Hello students, welcome in chemistry class. Let's we discuss about the orbital theory. We have already discussed about the energy order of different orbital, so anti-bonding and bonding, and how can we write the electronic configuration of given molecular orbital. So let's we recall at first H2, H2 plus and H2 minus. So how can we fill the electron and how can we represent their magnetic property, their stability, so on. So and at first H2 contains 2 electrons, H2 plus contains 1 electron, H2 minus contains 3 electrons. And as we study about the energy order of microorbital, sigma 1s, then sigma anti-bonding 1s, then sigma 2s, then sigma anti-bonding 2s, then sigma 2px, then pi 2pz equal to pi 2py, and then pi anti-bonding 2pz equal to pi anti-bonding 2py, and sigma anti-bonding 2px. So this is the increasing order of molecular orbital. So write down the configuration of H2 molecules. H2 molecules, it has 2 electrons. So for H2 molecules we will write only sigma 1s2. Each molecular orbital contains only 2 electrons. So remember it. So sigma 1s2, and how can we find out the bond order, students? Nb minus Na means bonding, number of bonding molecular orbital minus number of anti-bonding molecular orbital by 2. So how many bonding molecular orbital? Only 2. Anti-bonding molecular orbital? No electron present in anti-bonding molecular orbital. So we will found one bond order, and representation of this like 1s hydrogen and 1s hydrogen. This atomic orbital when combined it form 2 molecular orbital, one sigma 1s and another anti-bonding sigma 1s. So complete it. So it has sigma 1s2, no electron present in anti-bonding molecular orbital, and number of unpaired electron is present in this? No unpaired electron. So magnetic character of H2 molecule becomes, magnetic character is a diamagnetic. So students, in this way you can find out H2 plus, H2 minus, so on. So write down the next relative energy order of the different molecular orbital in case of nitrogen, oxygen, fluorine, so on. So at first see one important things here. Sigma 1s bond, anti-bonding, and sigma 1s bonding sigma 1s, and sigma anti-bonding 2s, sigma bonding 2s, then sigma pi this, and sigma bonding x, then sigma bonding x, then pi anti-bonding y, pi anti-bonding z, pi antibonding, pi antibonding Z and Y. So this is the, and at last sigma antibonding X and sigma antibonding X. So student, see here what I am trying to explain. This is the energy increases, and here also energy increases. So at first molecules like lithium, like beryllium, like boron, like carbon, like nitrogen, we use this type of increasing order of orbital. Sigma 1s, sigma 1s bonding, sigma anti-bonding, sigma 2s, sigma anti-bonding 2s. Then we use pi bonding X and pi bonding Y. Then we use sigma bonding X. Then we use sigma anti-bonding pi Y and pi Z. Then we use sigma bonding X. But in case of, suppose in case of oxygen and fluorine and neon. So in case of this molecule, whenever we try to write the configuration, at first sigma 1s, then we use sigma anti-bonding 1s, then we use sigma 2s, then we use sigma anti-bonding 2s. After that we use sigma bonding X. So at first we fill the sigma. See here, in the case of oxygen, fluorine, neon, sigma bonding X orbital first filled, then after we will fill sigma, pi Y and pi bonding Z. Then we use, this is the difference while filling the electrons of molecule of lithium, beryllium, boron, carbon and nitrogen. But in the case of oxygen, fluorine, neon, sigma bonding X first fill, then after we fill pi bonding molecular orbital. So this is the only difference during the filling of electrons in the orbitals of oxygen, fluorine, neon. So beware, be careful while filling the electrons in case of oxygen, fluorine, neon. At first, in both the cases, these 4 electrons present in molecules are common, but after that, in case of lithium, beryllium, boron, carbon, nitrogen, pi X, pi Y and pi Z comes first, then after comes sigma bonding X orbital. But in case of oxygen, fluorine, neon, sigma bonding X orbital will come first, then after pi Y and pi Z bonding orbital will be formed. After that, here is no difference. Here is no difference. Only difference is there. Only difference is there, and all the electrons filling in different orbitals are same in all the conditions except this. So remember this. In case of oxygen, fluorine, neon, you will first fill the electron in sigma bonding X orbital and px orbital. X orbital, I mean to say px orbital. We take the X, Y and Z. This axis we take the X axis. So, but in case of lithium, beryllium, boron, nitrogen, apart from this, oxygen, fluorine, neon, apart from this, all the molecules containing electrons is filled in this order. Sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s, then pi, py, pi, pz, then sigma 2px, then pi anti-bonding y and z, then sigma anti-bonding x orbital. But in case of oxygen, fluorine, neon, sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s. So after that you will fill the electrons in this molecular orbital, means sigma 2px, not 2, sigma x orbital. After that electrons goes in the pi orbitals y and z, and after that all anti-bonding orbital contains electrons. So students, let's we discuss about the next. Suppose we write down the configuration of oxygen. So we use how many electrons oxygen have? 8 and 2, total 16 electrons. Total 16 electrons in case of oxygen. So remember it. At first we write down the sigma 1s2, then sigma anti-bonding 1s2, then sigma 2s 2 means 2 electrons, then sigma anti-bonding 2s2, and after that we will use sigma bonding px orbital, sigma bonding px orbital, and after that pi y2 and pi z2, 2, 4, 6, 8, 10, 12 and 14. So after we will fill anti-bonding y and pi, anti-bonding z. So how many electrons are left? 2, 4, 6, 8, 10, 12, 14, 15 and 16. So each orbital contains 1 electron. So what will be the properties? So at first find out the bond order of, bond order means Mb minus Na by 2. So count the bonding electrons: 2, 4, 2, 6, 8 and 10. 10. Count the anti-bonding: 2, 4 and 6 by 2. So it comes 2. So bond order of oxygen is 2. In this way you can find out the bond order of the electrons, bond order of the molecules, and magnetic character. So this orbitals contains unpaired electron. So unpaired electrons means it has paramagnetic character. So students, in this way you can find out the property of the oxygen molecules by writing the correct electronic configuration. So in case of oxygen, fluorine neon, this orbital come first, and except oxygen, fluorine neon, this orbital come first, and this goes between this goes between this to this. Here will be place of this orbital. But in case of oxygen, fluorine neon, you will fill the electrons in this sigma px 2px orbital first. So find out the O2 plus, O2 minus and O2 2 minus. This is assignment. Find out the bond order and their magnetic property. Magnetic properties. Let's we discuss about the helium molecule. Helium molecules means total number of electron is 4. So write down the configuration: sigma 1s2, sigma anti-bonding 1s2. So find out the bond order of the helium. So students, bond order Nb minus Na by 2. So bonding 2, anti-bonding 2 by 2. So students, it comes 0. It comes 0. So the bond order, if the bond order comes 0, that means the molecules is not exist or not stable in nature. That is the reason helium molecules are not exist in nature. So on the basis of orbital, it is clear which molecules exist in nature and which ones will be not exist in nature. So next, suppose we write down the configuration of lithium. So let's we discuss the configuration of lithium, or suppose we write down the configuration of nitrogen. Total number of electron is 14. So write down the sigma 1s2, sigma anti-bonding 1s2, sigma 2s2, sigma anti-bonding 2s2. Then after pi pz2, pi py2, 2, 4, 6, 8, 10, 12. Then after sigma 2p x 2. Then after pi anti-bonding 2px 2pz, not x, 2px 2pz, and pi anti-bonding 2py. So count it: 2, 4, 6, 8, 10, 12, 14, 14. So this will become vacant. Now find out the bond order. 2, 4, 6, 8 and 10. Anti-bonding 2 and 4. 2. 6 by 2, it comes 3. So bond order of nitrogen is 3 means this is the formation of bond order. And what about the magnetic property? So see here, the last molecular orbital is filled, no unpaired electron is present. That means the character is diamagnetic in nature. So students, how can we represent by this diagram? So see here, sigma 1s2, sigma 1s2 like this. Nitrogen, one S, this is for one nitrogen atom, this is another nitrogen atom, this is sigma 1s, and this is sigma anti-bonding 1s. Another you represent like this, 2s for 2s, this is for 1s, this is for 1s, and represent for 2s. Sigma 2s and sigma anti-bonding 2s. After this we will draw like this for P, Px, Py and Pz, Px, Py and Pz, and each contains 1 electrons. So formation of bonding and anti-bonding takes place. So at first pi, so this is 1s, this is 1s, sigma 1s and sigma anti-bonding s. This is for 2s, sigma 2s and sigma anti-bonding 2s. For this 2p orbital, this is also 2p orbital. So at first form the pi 2p x, not x, pi 2pz and pi 2py. And a student, here will be form sigma 2px at first. Sigma 2px first. Sigma 2px, and after that here the formation of anti-bonding takes place. So here pi anti-bonding 2pz, pi anti-bonding 2py, and highest energy has pi anti-bonding 2px. So in this way you can fill the electron present in the nitrogen. So this is for 1s2, 1s2, here will be 1s2, this is 2 anti-bonding for 2s2, 2s2, 2s2 and 2s2. But in case of this, so see here pi 2p2, pi 2p2. So this is the pi 2p2. So complete here 2p2, pi 2p2. And after that sigma 2p. So here is the 2p2. And this becomes vacant. So in this way you can draw the structure and try to find out the molecular orbital, try to find out the magnetic property, try to find out the bond order. So at first try to draw the structure of different types of nitrogen. Suppose if you have given N2 and N2 plus, and after filling the electrons in different molecular orbital, differentiate which one will be paramagnetic, which one will be diamagnetic, and what will be the stability order of the nitrogen molecules and nitrogen plus molecules, which one will be stable, which one will be not stable. So simply if N2 plus is given, that means 1 electron less. So here the total number of electrons becomes 13. Total number of electrons becomes 13. So sigma 2px contains only 1 electrons. In case of N2 plus, sigma 2px contains 1 electron. So all the structure will be similar, only the changes takes place in the molecular orbital of sigma 2px. This contains 1 electrons. In this way you can change the bond order also and magnetic property also. Means this contain, if this contain 1 unpaired electrons, so N2 plus becomes paramagnetic, not diamagnetic, and the bond order also becomes changes, because here the bonding molecular orbital 2, 4, 6, 8 and 10, 2, 4, 6, 8 and 10. But in case 1 electron, here the bonding molecular orbital contains 9 electrons. In this way bond order becomes changes. So find out write down the electronic configuration and find out the magnetic character or bond order. So N2 plus and N2 minus. So students, try to do this. So that's enough for today. We will discuss after the completion of this topic. We will discuss in the in-text question or exercise question related to this topic. Try to do this, work hard and be sincere towards the studies, and pay more attention and more time to chemical bonding chapter. And at Friday we will discuss whatever our doubts or and another things also.